first is machine learning using PyCaret. So open the link. So it will redirect you to my GitHub page. And there are 4 notebooks. So IPYNB is the notebook in extension. So that is interactive Python notebook. So before moving forward, a very brief introduction about PyCaret. So it is a bundle of many machine learning algorithms. Only 3 lines of code is required to compare 20 models. So class, it is very, very important whenever you got some data. So very first objective is to find out which model work better on my data set. So for this, we need to compare multiple models. Now PyCaret is available for classification, regression, and clustering. So there is a small self-learning resource. So you can directly right click and open in a new tab. If you click here, it will open in the same window. So if you want to learn more about PyCaret, so just right click and open in a new tab. So we just don't do this. So in this today's 2-hour session, we are going to learn many things like how to create a model, how to automatically tune the hyperparameters, how to find the best model, how to save it, and how to make the prediction on the new or unseen dataset. So class, as I already told you, only 3 lines of code is required. Okay, so let's suppose this is a sample code. So these are the first 2 lines are nothing but importing a library. And these are the 3 new lines. Okay. So what's very first is getting the data set. In the next, we call a function setup that requires some data input. And finally, we need to call a function that is known as compare models. So these 3 lines of code that we need to run, and that will compare different machine learning models on different evaluation parameters. So class, just see on the screen, if your data set is of regression, then this table will be generated. Okay, so these are some models and these are some evaluation parameter like mean absolute error, mean square error, mean root mean square error, R square, and 2 other parameters. Similarly, if your data is of classification, means discrete, then these 3 lines will generate this type of table. First, different models, then evaluation parameters like accuracy, AUC is area under the curve, recall, precision, F1, kappa, MCC. And third, if your data set is of clustering type, means unsupervised learning, then this type of table will be generated. So all these things we're going to cover today. So now very first, just click on regression, right click and open the regression notebook. Chale class, make it fast. Just right click and open in a new tab. So this is a regression notebook. So this is the content that we are going to practice today. If you scroll it down, there are many things are there, many results are there. And if you come to step number 1.2, so this is the data set. 1.3, some setup function, and 1.4 is the result set. So this is the thing that we are going to run today. So please click on Open in Colab. So there is a button with the name Open in Colab. चलिए class, click करिए इस पे, just open it. Just click on Open in Colab. So it automatically link to the Colab. So I hope some of you know what is Colab is. So Colab is nothing but a online browser-based environment. So you can run your code, your project in a browser, and that is hosted at a Google server. Just see on the link. In the URL, it is Google. So the CO is the Google Colab. This is my notebook name. And these are the things that we are going to run today. So class, before moving forward, are you able to open the Google Colab notebook? Regression wali?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
Perfect. Very good, very good. That's good. And I am expecting you know about some basics of the machine learning, like classification data and regression data. If no, if you don't know, then no issues. Just I will explain you in just 1 minute. So class, this notebook will open in your Google Colab. The very first step is copy to drive. So just click on this button. So this notebook will copy to your own Google Drive. So click on this copy to drive. So this will create a copy of this notebook to your Google Drive. So it will be stored in your Google Drive again. So just click once. So Google Colab is the environment. It's a browser-based environment that run the Jupyter notebooks. And the best part about the Jupyter notebook is Google Colab is that sharing. So just see on my screen. So there is a share button. If you click on this button, and let's suppose few team members are working together, so just add the team members and just define which type of permission you want to give. You want to make it viewer, you want to make it comment, or you want to give the editor so that he or she can also edit the same notebook. And if you want to notify them, just check it. If you don't notify them, no issues, and then send. So this invitation will send to these three peoples. They can also view and edit this same notebook. So it will be helpful when you are working in a collaborative environment. Chaliye. So right now I am just skipping this part. So you can easily share. So this is the Google Colab environment. The very first step is to connect. So class, just click on this button, connect. So after connection, it will connect to the Google server and it will allocate some resources to you. Resources means some RAM and some disk. So if you bring your mouse over RAM and disk, you will get total 12.67 GB is allocated, in which 1.19 is I am currently using, and total 107 GB of space is disk space is provided, and 32 GB of space is currently using. So now please let me know everyone connected, yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Very good, very good, very good. So there class, now there are a few links. If you
Can
learn
we
more about PyCaret, then right click, open in a new tab. Don't directly click on this link, because if you click on this link, it will open in the same window. So all your work in the Google Colab will lost. Okay. Now, so there's a small document regarding PyCaret regression. And in this tutorial, you are going to learn about data, environment, model, tune, finalize, predict, and save. So class, very first step is to install this package. So now just click on step number A. So to execute any shell in Notebook or Google Colab, there are two options. Either you click on this button or just click on the shell and press Control Enter. So I recommend you should use Control Enter. So now it is installing the PyCaret package in my environment, and that installation is temporary. If you close this window or you log out from the Google Colab, then everything will be zero. So there are two versions. This is a Colab version, free version is there. So there is another version is known as Google Plus, Colab Plus. So that is a paid version, and it charges nearly $10 or $12 per month. So if you would like to work on that, you can purchase that. So there are some advantages like your intermediate result will save, and you will get a long execution time on Google server. So now step number A is executed successfully. And so to install any package in Python, so there is a command known as pip install package. But I am installing in Notebook. Notebook can be your Collab or your Jupyter Notebook. So you need to put exclamation sign. So that suggests that this installation is done in through any notebook or in the Google Colab. And after that, I am just assigning the intermediate result to this null directory. And after installation, it is just showing me a message. The PyCaret installed successfully. Okay, so I think this is simple thing. Next, execute step number B. Just press Control Enter. And in Collab or in Jupyter Notebook, you see a blue tick, a green tick is there. So that suggests that that particular shell is already executed. Okay. So now current version is 3.3.2. That is the PyCaret version. Now if you run the same code after 1 month, so there must be some increment or bug fixing in the same package. So you will find an upgraded version also. So now the very first step is installing the PyCaret. So class, is it done by all? Yes, no?
Yes, sir.
Yes, sir.
Perfect. And what about the others? There are only 3 students in the class, yeah? So rahe ho kya?
Done, sir, done.
Done.
Done,
That's
sir.
good. That's good. Now, come to the step number 1.1. So class, in 1.1, we are get a list of data set available with PyCaret. So there are 55 data sets that is by default available with the PyCaret package. So just see on the screen, just press Control Enter. So we are importing PyCaret.dataset, and we are importing a function with the name getData. And after that, importing getData, we just pass index and showing to the store to the dataset. So very first is importing library, and next step we are calling a function with the name getData. And after that, we are just passing index. So you just see here, there are 55 dataset is available. If you scroll it down, the 55 plus 0, 56 dataset is available. So these are the name of the dataset. This is the dataset name. What is the dataset type? So there are 2 types, multivariate or univariate. So in real life example, 99% of the dataset is multivariate. Multivariate means you have one target column, one output column, and multiple input columns are there. Second, what is the default task? Should we perform anomaly detection? Are we performing association mining? Are we performing classification of binary classification? Are we performing multi-class classification, clustering, NLP, regression? So this particular data set is available for these default tasks. Next is target column. So what is the target column for my data set? So now if it is a supervised learning, target column is there. It can be a classification or it can be regression. And if your data set is of unsupervised, then label column is missing. Then number of instances means number of rows, number of attributes means number of columns, and is there any missing value? Yes or no? So all the 55 data sets are very neat and clean, so that we can easily understand what exactly the workflow is there. So just execute 1.1. Now come to step number 1.2. Just execute. So class, this is a self-explanatory notebook. You need to just spend at least 1 hour. You can complete the notebook and you'll love this package. And this package is created by like you and me only. In the back end, sklearn library is used. Okay. So now class, this is a step number 1. I told you there are 3 lines of code that is required to compare multiple models, 20 models nearly. The very first step is dataset. So just see, I am calling a function with the name get data and I am passing Boston. So now what exactly it did? It pulled the dataset from the PyCaret library and assigned to the Boston dataset variable. Okay, class? And just see, it shows top 5 datasets. These are the features and target column is MEDV. So now just browse and just come to step number 46. So just come to step number 46, dataset number 46. So this is a dataset, Boston. It is a multivariate. It is for regression. So MEDV is the target column. So just see here, MEDV is the target column. It contains 506 rows and 14 columns are there. Okay. So now let's work on this dataset. The very first step is dataset loading. Now step number 1.3. So actually this is step number 2. We are just importing a library with the name pycaret.regression. Okay. Now, so there is a function with the name setup. So there are 2 parameters like dataset. So this is the same dataset that we just import in step number 1.2, Boston dataset. And second is target column. So target column is MEDV. So this is my MEDV. Okay. Just execute this step. So class, this is line number 2. We are calling a setup function. So in setup function, we are just defining ki dataset kaun sa hai and which is the target column. That's it. By default, data in this setup function, by default training is 70%. So let's suppose you want to change. So क्या करना है आपको? Comma, paste. And let's suppose you want to give 60% in the training. So train underscore size, just give 0.6. So 0.6 मतलब 60% and press Control Enter. Okay. Now if you want to make it 0.8, so just make it 0.8. If you make it 0.7, so this is a default parameter. So similarly, the next parameter is data split shuffle. If you want to shuffle the data row wise, okay. If you want it, then make it true. If you don't want it, make it false. Okay. So this is step number 2. So right now, just I am selecting the train size equal to 0.7 and execute it. So setup function is assigning some parameters values that I will discuss in the next 2-3 next step. Now execute 1.4. Run all models. So this is the last step. So there is a function with the name compare underscore model. Execute करो उसको. Just press Control Enter. So we are calling a compare underscore model. This is an inbuilt function. And in the back end, it will run all the models, train all the models, test it. And after that, compare these evaluation parameters. It is still running. Now it is done. So class, in regression, the very important parameter is R square. So it sorts all the models according to R square value. So means GBR is the best model that gives the R square value is 0.7. Similarly, extra T regressor, these are the models name and these are the some values. Okay, class. So are you getting something? Yes or no?
Yes,
Yes,
sir.
sir.
Only two? What about others? Harish, Shalja.
Yes, sir.
Yes, sir.
That's good. That's good. Now come to step number 1.5. So class, these are the, I combine all the three line of code, okay, in a single shell and just run it. So first three lines are some importing some libraries, and next three lines are just getting the data set, calling a set of function, and calling a compare model. So class, this time in 1.5, we all are getting the same result. R square is equal to 0.72223. Now, if you want to make the data shuffle, so make it true. So class, just change data split shuffle equal to true and rerun the code. So means it will shuffle the data internally, row wise, okay? And after that, it will train all the models, test on the testing data set, and after that, it will calculate some evaluation parameters and just merge into a single table. So class, just see how simple it is. In a single, in just three line of code, I am able to compare multiple models. Okay, just see here, this time I'm getting R square value is 0.90. So what is your R square maximum best R square value? Please write in the chat and model name. Write the model name and R square value in the chat. Shalja, model is already implemented. We are just calling through this library. So in the backend, sklearn library is there. Now, if you go to the just write sklearn. Scikit-learn library is there. So that is designed and developed by Google and maintained by Google. So if you click on this library, sklearn library, so in the backend, all the models library are available. Okay. So PyCaret is just developed by you people like me, you, or any similar people. So it integrate all the models by running just these three lines. Okay. So now just see how much simple it is to compare multiple models. And now this table is required whenever you are writing a research paper. Okay, so whenever we are in the process of writing a research paper, we need to compare multiple models. Okay, Monica, good. Abhishek, Shabash, Bhagyashri, Joga sir, you got only 0.65 best model. Okay, no shoes. Joga sir, try it again, execute again. So every time you run this code, you will get a different model. That means different accuracy by different model. So just execute 1.5 step again. Because we make and we force them ki yes, data split should be shuffle. And this time you will find you will get a different accuracy and different R square value. Now it is done. I'm getting 0.84. Now if you make it false, then no shuffling is allowed. So what happened in this data set? Let's just see on the screen. So let's suppose you have a data set from 1 to 1000. So if I am just disallow the shuffling, then top 70% data will go for the training and remaining data set will be available for the testing part. So if you make it false, so everyone will get the same result. Okay. So now class, why it is important to shuffle the data? Let me explain with some example. So now why shuffling is important? Let's suppose I am taking this data set and my last column is class or target class, and that consists of so class this data set consists of 19 rows, and if I'm saying that 70% data should go for training and remaining data go for testing, and let's suppose I am not shuffling and I'm selecting, let's suppose this is a 30% data set and this is my training data set and remaining all my testing data set. Are you getting? So just visualize here, just see here, my all the ones are gone to the training data set. My all data set will go for the training and remaining data go for the testing part. Just see here, my data set in the training contain all ones and few number of zeros. Okay. Now, if I want to shuffle it, so what is the process to shuffle? So class, just see here, I am in Excel. So let's suppose I am creating a new features. I am adding a new class. Let's suppose I am giving name Z. So I'm calling a random function. Just see on my screen. इसको मुझे shuffle करना है. So I call a random function. I double click it. Random number generate हो गए 0 1 के बीच में. Just click on I. I'm going to sort smaller to larger. So you just see it is asking ki yes expand, and I'm shuffling. So just see my target column is also got shuffled. Now if you sort again, anything you can choose anything, smaller to larger or larger to smaller. So every time my data got shuffled. So this is the importance of data shuffling. Otherwise, just see my result. I am only getting 0.6, 0.70. So 0.70 is not good R-square value. So class, are you getting something? Yes, no? Yes, Bhagyashree, you can also try. We just next step is the same thing. We are trying our own data set. So clear hai sabhi ko? Yes, no? Perfect. That's good. Chaliye. Now come to step number 1.6. So now this time we are running our complete model for the insurance data set. So insurance is one of the data set available in the PyCaret. So just execute 1.6. So 1.7, 1.6 is running the same code, all the library on PyCaret on insurance data set. So in the very first step, we are just pulling the data from PyCaret library. After that, we call a setup function in which we need to define the data set and target column is charges. So just come to step number 1.2. sorry, 1.1, and just find where the insurance data is. Yes, insurance data is this much. Serial number 53. So it is a multivariate data set. It is regression type. Charges is the column. 1338 are the number of rows, and 7 number of columns are there. Okay. So just come to 1.6. So after running this code, we find out that my GBR, again, gradient boosting regressor, give the R square value. Okay. So class, this is the advantage of PyCaret. Otherwise, क्या करना होता है आपको? You need to import all the models. You need to find how to train them, how to optimize the parameter. After that, you need to run all the models. And after running the model on train the model, you need to perform the testing on the testing data set. And after that, you need to merge all the result in this table. So all these things will be done only in 3 lines of code. Okay, so this is the beauty of PyCaret. Chaliye, let's move forward. And before moving forward, do you have any question, query?
हेलो
Yes, Monica ma'am.
सर आपने ये डेटा रिग्रेशन वाला ओपन किया पूरा स्टेप्स के साथ में कॉलैब के अंदर राइट
Yes, ma'am.
एंड देन आई हैव रन वंस फर्स्ट स्टेप it is giving some error like in the first line from pycaret.datasets import get data. Have you imported some data in this drive
No,
of
no, no, no,
Colab drive?
no. Ma'am, before going to running the step number 1, you need to install the package. Step number A and step number B.
Okay sir.
तो ये PyCaret पैकेज इंस्टॉल हो जाएगा. आफ्टर दैट उसमें हमने ये इंपोर्ट किया है.
Okay, okay sir, got it.
ठीक है. अगर आपने इसको इंस्टॉल नहीं किया PyCaret को, देन वो एरर देगा. So
Okay.
any other question query? यार yes no तो लिख दीजिए एक बार.
No sir.
Okay, let's move forward. Come to step number 2. Yes. So class, how to use PyCaret for my own data set? Okay. So now class, I send you a link. So just download fuel cell dataset. I am sending the dataset again in the chat. So just download fuel dataset and open it. Yes. Open क्या सभी ने? Yes, no?
Yes, sir.
Great. So now just press Control down arrow. Just press Control down arrow. So it will take you to the last line of the data set. So that is 1000 data set. Control up arrow. Control right arrow. So you will move to the last column and control left arrow. So now if you select and double click, you will see we are clearly seeing the column name also. So class, very first is temperature in Celsius, pressure, humidity, hydrogen flow rate, air flow rate, membrane thickness, blah, 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 cell voltage. Joga sir, please mute yourself. So class, this is a जो data set है ये fuel cell का. जो हाइड्रोजन सेल है हमारे उसका एक डेटा सेट है हमारे पास. And the last column is my target column. So we have different properties, different environment, humidity, temperature, pressure, cell comparison, multiple things are there. And the last column is my cell voltage. How much voltage a cell can produce. So this is a target column. And you clearly see these values of real values, float value. So this is known as continuous value also, and so that's why this is a data set of regression. So clear hai sabhi ko? Yes, no? This is a data set of regression. That's good. Very good. So now class, this data set we are going to use for this current experiment. Now just close this file and again come to step number 2. So class, just read the instruction that I wrote in the shell. So first, in the very first step, first upload the user file, means your data file in the collab. तो कहाँ पे upload करेंगे? So there is a folder. Just click on this folder. Class, just see on my screen. Let me do it again for you. So there is a folder. Click करो उस पे. And there is a button with the name upload to session storage. So there is a button. Click करो उस पे. And just select the file name. So I'm selecting fuel cell performance data. Open it. So my file is uploaded. सबने किया? Yes, no? हमने कुछ नहीं किया. गूगल ड्राइव पे गूगल कोलैब में हमने अपना डेटा को फाइल अपलोड किया. ओके, वेरी गुड, वेरी गुड, शाबाश. अब नाउ जस्ट क्लिक ऑन दीज थ्री डॉट्स, कॉपी पाथ. जो फाइल अपलोड हुई है उसको कॉपी पाथ को कॉपी करिए. जस्ट क्लिक एंड ये जो 3 लाइन है इनको अनकमेंट कर दो एक बार. वन बाय वन करते हैं. एक काम करो, जस्ट पेस्ट योर फाइल नेम हियर. Just paste your file name here and press Ctrl Enter. And it is not showing the. So just write down the variable name. Press Ctrl Enter again. So just see, it is showing my data set. So class, are you able to read the file? Yes, no? Just see on my screen what I did here. I just click on the file uploaded, click on these 3 dots, copy path. And copy path में मैंने पहले इस फाइल को uncomment किया and just paste the file name. So are you able to, and just write the variable name. It will show you the top 5 and bottom 5 records of a file. Okay, now just move the column to the right, extreme right, and copy the column name, cell underscore voltage. Copy करो उसको. Now next, uncomment the setup file, setup comment. So data set name is data set, no change. Target column is change. So just replace target and paste. Again, remove the uncomment the compare models. I am removing my data set. And just press Ctrl Enter. So class, are you getting something? Yes or no? If we are able to run the PyCaret for my own data set. So class, are you able to run? Yes or no? Error in first line. So Bhagyashri, what is the error? Just see my code, what exactly I did here.
So something related to indent.
Indent means, just see, if you give any space, just see on my screen. This is the space, just remove the space.
Okay, sir.
So class, make it fast. Class done. So just see here, my R square value is just 0.1, 0.19. So that is very, very poor. Means no model is giving my R square value is greater than 0.2. Okay. So by doing this way, we are just showing this is the way we can get that we are able to run multiple models on our own data set. So class, easy hai, yes, no? Class, yes, no? Easy hai? Great, 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 great. Very good. Chaliye. So this is all about the working with the user data set. Now come to step number 3. Now just come to step number 3. So class, in step number 3, we are applying data pre-processing. Okay. So now before moving forward, so class, if I'm asking you a simple question, how many ways we can improve the performance? Yes, Mansi, ask your question. Mansi? Okay, no issues. Okay, now I am asking a simple question. How many ways we can improve the performance of a model? Please write your answer in the chat.
By cleaning the data.
By cleaning the data, very good. और बताइए. Cross validation, better training data, by removing noise, very good. Okay, done. So class, all these things that you are writing in the chat, change of algorithm, okay, done. This is a part of data pre-processing. So if you ask the same question with me, if you ask the same question to me, so there are 2 ways through which we can improve the performance. Number 1, data pre-processing, that consists of all the things that you are telling in the chat. And second is model performance, changing the, optimize the model parameters. Okay, so these are the 2 things through which we can improve the performance. Very first is data pre-processing. All the things that you write in the chat, that is come under data pre-processing. And second, tuning the model parameter. Okay, so now we'll do all these things in this notebook. Now, so class, come to 3.1. Just execute 3.1. Just simply execute. So class, the very first step in the data processing is normalization. Mansi, that let's suppose you are running in a race. You are the alone running in a race. You always come first. To check the performance of your running, you need to compare with different runners. Okay, the same thing happen in the in the machine learning. Whenever you have some data, you need to run multiple models to check which model gives the best performance. After finding the best model, you can go for the deployment. Okay, now so class in just see in step number 3.1. So we are applying normalization. So can anyone explain what normalization is? Anyone?
So to reduce the redundancy and duplicacy of data and convert the data or fetch the data from the bulk of data set to be in a normalized or understandable format or in a organized format.
नहीं गलत आंसर है. Monica, this is not the true definition of normalization.
To set our data in a range 0 to 1.
Exactly. Not only in the 0 to 1, in the scale, same scale. So class, let's suppose you have 5 parameters: age, student age, student height, student weight, student CGPA, and salary of the student. Okay, all these 5 parameters are in different range. So if you want to visualize all these 5 parameters in a single scale, it is very difficult. So to view all these things in a same scale, you need to normalize it. So generally, a very simple normalization technique is that we select the maximum value in a row, in a column, and we divide it. So that make all the data in the range of 0 and 1. Okay. So normalization is nothing but to bring all the value in the same scale. So now, so class, just let's suppose you want to apply normalization on your data set and you want to know the performance. After applying normalization, which model gives the best? Which model gives the best accuracy? So now what I did here in the setup function, first I make normalization equal to true. Because this is very important. And after that, which normalization method I want to use? So I want to use normalize method equal to z-score. Okay. So you run it and you find out the R square value I am getting 7.1. So that is the better performance rather than without applying normalization. Similarly, there are a few more methods are available like min max. So just copy and just replace with z-score and control enter. So class, there are multiple normalization method, and we want to know which method give the highest accuracy or highest R square value. Then we need to run it. Without running, you cannot predict which parameter or which normalization technique give the best accuracy part. So similarly, after min-max, you need to run max absolute, and also you can try robust. So these are the 4 normalized methods. And if you want to know more about these methods, kindly Google it, watch some videos on YouTube. So they will clearly explain how these 4 different normalization technique works. Okay. So now after applying min max, I am getting my R square is 0.7. So that is the lower than the Z score. So similarly, you can try different other method also. So the beauty here is that by changing only one parameter, you can able to normalize the complete data set. By changing the same parameter, single parameter, you are able to apply different normalization methods. Otherwise, you need to write a separate program to apply the normalization. After that, you need to retrain all the models. After that, you need to collect the result and you need to showcase in the similar table. So just see how simple it is. By changing just parameter, I can able to run, I can able to analyze the data of model performance, okay, on different evaluation parameters. So class 3.1 सबको समझ में आया? Yes or no? Please write at least yes or no.
Sir, normalization means only to fit the whole parameter in a single scale.
Yes, ma'am.
Any other attribute related to normalization of the data?
Normalization is just a technique. Let's suppose I told you 5 parameters are there and you want to visualize all these parameters single scale, single graph. Okay, because take an example. Normalization cannot help us to remove the outliers. Okay, now take an example of a normal I will cover the outliers. क्या होता है? So just let's suppose I am putting all the values. So CGPA value is between 0 and 10. But my salary value is from 0 to 2 lakh. Okay, 0 to 3 lakh. So if you put both the values CGPA and salary, so salary will go much higher than the CGPA. You cannot visualize in a single graph. Okay, so that's why we need to perform normalization. So the class, this is the very first data pre-processing part, that is normalization. Yes, ma'am. Anyone else? Any query?
Thank you, sir.
Okay. Now come to 3.2. Feature selection. Now just run it. Just run 3.2. Just run 3.2. So again, feature selection is a part of data pre-processing. Let's suppose my data consists of 100 columns. Class, just see here. My data set consists of 100 columns. And I want to select which model give me the best, which columns should we select so that we will get the best accuracy. So class, there are some issue with the light GBM model. It is not able to run properly. So just scroll it down and you can easily find that after applying the feature selection, I am getting R square value is 0.68. Okay, now just analyze the code again. Just come to 3.2. So now we are talking about feature selection. So feature selection is that, let's suppose you have 1,000 features, 1,000 columns. Columns are features, or 100 columns. And you need to select top 10 top 10 features. Okay. So this is the way we can select the features. Now class, just see here. In the setup function again, data set name and target column is the same. No change is there. But in the feature selection, first I make it true. Yes, apply feature selection. After that, which feature selection method I need to apply? The feature selection method equal to classic. So just see here, the thing that I commented. So there are 3 methods of feature selection. Number 1 is classic. Next is univariate. Next is sequential. Okay. So class, this is all about the feature selection method. But one more important thing I selected here, features to select 0.02. Now, what is the meaning of 0.02? Okay. So class, just come to step number 6.1. Just scroll it down. Just scroll it down and come to step number 6.1. Class, make it fast. Come to step number 6.1. Now just see here. So these are the features of Boston dataset. and this is the variable importance. So 0, 0.0, 0, 0.1, 0, 0.2, 0, 0.3, 0, 0.4. Okay. So just clearly see that R, M, and L state are the top two important features. Are you getting class? So 0.2, 0.3 is the weight is the some variable importance variable. So this is the visualization of the feature importance. Means the best feature is RM, next best is L state, third best is dis, fourth is crim, nox, age. So similar, all the parameters are arranging and visualized in the same in a single graph. Okay. Now come back to step number 3.2. So just see the code again. So class, feature selection equal to true. Feature selection method is classic. Number of features to select 0.02. So this is the cutoff. So I am selecting 0.2. 0.2 means we are selecting only top two features. You can also try with 0.1. You can also try with 0.1. Okay, and you can see just what is the performance of the models. Class, are you getting? So this is the beauty of PyCaret. You can apply feature selection. Okay, you can apply normalization. So you need to just change the parameter value. So class, are you getting yes or no? That's good. Great. Now again come to step number 3.3, outliers. So before moving forward, please let me know what is outlier. Class, unmute yourself and let me know what is outlier.
Sir, any value which is very far away from the mean value.
Exactly. बहुत बढ़िया. Very good. So this is very good, Joga sir. And the extreme value is known as outliers. Take an example. There is a class of 100 students and pocket money of students and salary of a teacher. Okay. So the salary of a teacher is obvious is outlier, extreme value. Okay. So now we want to know if we are removing the outliers, what is the performance or what is the effect on the model performance. So just see here in the again setup function, we call a variable, we set a variable outlier, remove outlier equal to true. Class, one more thing. These are the predefined variables of the setup function. Okay. So I just write remove outlier equal to true. This is the first. This is the first parameter. First, I need to make it true. After that, there are several methods that can use to remove the outlier. So outlier method is equal to iForest. Okay. So just see in the last line, there is a double E method. There is one more method is LOF. So you are requested to learn what are the different outlier methods, what is the mathematics, and how exactly they are implemented. So very first parameter, remove outlier equal to true, outlier method equal to iForest, and this is a threshold value. So three things that you should know. So threshold means I set 0.05, means it is 5%, 2.5% from the right and 2.5% from the left. You can also select, you can also make it 0.1. So 0.1 means 10%. Okay. You need to remove 5% from the right side and 5% from the left side. Because the outlier can be in the above also, and it can be in the below also. Okay. So 0.1 means 10%. So 10% means we are removing 5% from the right side and 5% from the left side. Now rerun the code. I am running with the 0.1. We want to know what is the effect of outlier removal on the model performance. Make it fast. It is taking some time. Now it is done. And just see, after removing outlier, my R square values again goes down. Okay, so it is not helping me to improve the performance of the model. So class, is it clear till now? Yes or no? Okay, perfect. Clear. Now come to 3.4, transformation. So class, I would like to explain transformation with the example. Just see on my screen, I'm using a term known as transformation. Let's suppose there's a function with the name f1 and that consists of value between 1 and 100. So class, just see on the screen. So there's a feature with the name f1 and I want to transform. So transform means this is a new f1 and just see on my screen, I'm applying some rules like equal to if this value is less than 50, less than equal to 50, comma 1, comma 0, comma 0 and comma 1. Class, just see on my screen. I'm just creating a new column and I'm defining one rule. If the A2 value is less than 50, make it 0 and else make it 1. I'm making enter, double click, and you see my all the values are now between 0 and 1. So rather than using F1, I can use this new column also. So this is one of the transformation. Now you can select, you can choose other method also. Like if the value is less than greater than 25, make it 1. Okay, make it 0. Again, you can compare values less than equal to 50, make it 1. Okay, or if again A2 value is less than equal to 75, make it 2, else make it 3. Double click. So now this is again a different transformation. Okay, class. So it's totally depend on me how I can transform, how I can create a rule. Because the only objective is that I need to increase the performance by hook, by crook, कुछ भी मोड करके मुझे accuracy बढ़ानी है. So now in this data set, I am not going to use F1. I remove this column and I will replace this value, this column. Train the model again, check it the performance, and just let us know how exactly the model is going to perform. Okay, so just see 3.4 how the exact transformation equal to true, and there is a method of transformation is Yo Johnson. So here I exactly don't know how exactly Yo Johnson is transforming my data set, but let it run. Just run 3.4. and just check the performance of the model. Now, one more important thing, PyCaret will only work for the small data set up to 1000. Let's suppose you have 50,000 data set or 1 lakh data set, then PyCaret will not work. So in that particular case, select some sample. So there are sampling technique, different sampling technique. Just select some sample. Let's suppose you have 1 lakh data. So just select any 1000 data set from your 1 lakh data. Run PyCaret over 1000 data and just find out which model giving the best performance. So many times we observe that if you are select your data through some sampling techniques, so exactly the best model that work better in the sample, in the small sample, that also work on your complete data set. Okay, because in the back end multiple models are going to run, so it will take a long time. So it's highly recommended that don't run PyCaret on huge data set. Run it for only a small data set. Okay, so class, is it clear to all? Yes or no? That's good. That's good. Chaliye. Come to 3.5, PCA. PCA is also one of the important pre-processing technique known as principal component analysis. So class, nowadays nobody uses PCA because what exactly the PCA did, let's suppose you have a 10,000 data. So it uses in the earlier when we don't have the high performance computing. So we use the PCA. So what exactly PCA did, let's suppose you have 10,000 features. So in the image processing part, we have 10,000 features, 10,000 columns. So no algorithm is able to run on these 10,000 features. Okay. So we apply first PCA. So what exactly it did? It completely convert 10,000 features to my principal components. Yani it reduced the 10,000 features to 4 features or 5 features. And these new 5 features are known as principal components. And these 5 features are completely the new dimension data set. Okay. So now just run 3.5. Just run 3.5. Just run 3.5. So there are few methods for PCA. So by default is linear. Two more methods are there, kernel, incremental. So I request all of you kindly try this different combination and find out which PCA model give you the better accuracy. So just see here, we are getting R square value is 0.65. Okay. Although we studied PCA in theoretical part, we also teaches PCA to the students, but we never applied PCA on my own data set. So this is the PCA part. So it automatically, how exactly it works. So first make PCA equal to true and then PCA method equal to linear. So this is the simple 2 parameters that help us to apply PCA on my data set. After that, all the model will run and it shows the performance. So class, just see how simple and how it is so that we can perform any type of analysis on my data set. Okay, come to 3.6. If you want to apply multiple pre-processing techniques, let's suppose you want to apply outlier and as well as normalization. Okay, so in that case, you need to run like first outlier equal to true and outlier threshold equal to 0.05. After that, comma, normalize equal to true and normalize method equal to z-score. So just execute 3.6 and just check by applying two pre-processing technique. So is there any performance improvement? Just check. So class, this is a well-written library notebook. Okay. So whenever you are teaching to any students, so you can use, no copyright is there. You can modify this code, you can modify this notebook, and you can release with your name. Okay. But the thing is that we teach theory rather than practical part. So you can assign this task to perform in the lab also. Now, one important thing class here, this is very important, 3.6. So we are getting some improvement in R square value is 0.69. Okay, now we are applying two pre-processing, outlier and normalization. So which will run first? It is first removing the outlier, then normalization, or it is first normalize, then removing the outliers. So if you're giving the first parameter as remove outliers, then first it will remove the outliers. After that, it will remove the it will make the normalization. Now, if you change the order, so simply just make it write the normalization first, then remove outlier. It will change the order. Okay. So now I'm requesting all of you kindly rerun the code again. First normalization and remove outliers, and just check what is the variation in the result. Class, please run. So are you getting something? Yes or no? यार एटलीस्ट अनम्यूट करके ही बोल सकते हो या फिर चैट में भी लिख सकते हो.
Yes, sir. Very interesting, sir.
Yes, sir.
Thanks a lot.
थैंक यू सर, थैंक यू वेरी मच. यार ऐसा नहीं है कि मैं वन वे पढ़ा रहा हूँ, एटलीस्ट कम्युनिकेशन तो करो. यस नो? गुड. It is taking some time. Now it is done. Now it's showing some improvement. 0.7. Chaliye. Now class, similarly, now this time 3.7 I am not going to run. I'm just explaining you if you want to apply outlier, normalization and transformation in a single go. So just remove outlier true, outlier threshold. Normalization equal to true, you are defining normalization score. Transformation and transformation method. Okay, so run, and we see that 0.7 is the best out square value. Okay, chaliye. Now class 3.8, this is the most important manual about setup function. So I'm requesting all of you kindly right click and open in a new tab. Don't click on this link directly. If you click on, it will open the same link in this notebook itself. So all the work will gone. So just click on, right click, open in a new tab. So this is a redirect notice. Click on the very first link. Yes, you can redirect. Click here. So this is the complete manual for the setup function for regression. Okay, so just see how much parameters are there. It consists nearly 58 parameters. So just search for Control F normalization. Normalize. Press enter once again. So by default, just see, by default it is false. Search again, normalize method. So by default Z score. Once again, now this is the manual. So class, just see here. So by default it is false. Normalize method equal to by default method is Z score. And again, min max is there, max absolute is there, and robust is there. So all these parameters that I explained to you, it is already written in the manual. Similarly, just scroll it up. So transformation by default is false, and transformation method is Geo Johnson. So first you need to make transformation equal to true, and then you need to define the different method. Similarly, scroll up. Outlier removal. So remove outlier equal to false, and default is iForest. After that, there are three methods for the outlier remove: iForest, EE, and LOF. And this is a threshold value. Okay, and that is 0.05, means 0.5%. So 2.5 from the left, 2.5 from the right. So all these things that I explained to you in the notebook, it is a part of this setup function. I just select the important parameters and just explain to you. Class, are you getting something? Yes or no? Okay, good, very good. Now class, I am skipping this part because here I am just building one model. Okay, let's suppose your one model is getting best. So you can create that particular model usually. After that, you can save it. You can make the predictions. Step number 6. Sorry, just come to step number 5. Just execute step number 5.1. So here we are just creating a function with a model RF, random forest. Okay, and this is it run for 10 times, 10-fold, and you got different R square values, and the average R square value is 0.68. Execute step number 5.2. So there is a function with the name plot model. So there are two parameters. Number one, model name, जिसको हमने अभी train किया है, and the parameter is error. So just execute 5.2. It will clearly show you the regression line, or it is also known as error plot. Again, don't run 5.3. It will take some time. If you run it, so you will able to print the design the learning curve. Okay, as the number of instances, number of iteration epoch increases, how the training is going to increase. Similarly, 5.4, it is validation curve. So this is all about the printing part of the model. So I'm skipping this part. Now I'm moving to the step number 6. Class, this is the important, very important part of visualization of feature importance. So just execute 6.1. So this is the Boston data set, but let's suppose you want to know the feature importance of your own data set. Okay, so class, just see here. First, we are creating a model with the name RF, and we are using a function with the name plot model, and we are providing two parameters, RF model and plot equal to features. So just see all your feature will be plotted here. Okay. So this is the feature plotting using random forest. Come to step number 6.2. So here we are running a different model with the name extra tree regressor. So first we are training ET and just plot the features. Okay. So this is all about the feature importance, plotting the feature importance. So this is again 6.3 is using decision tree. Now, point number 7. This is the most important part of machine learning class. So till now we perform different pre-processing technique to improve the performance. So I told you earlier that there are two methods through which we can improve the performance. One is pre-processing part. We already did it. And the next is optimizing the parameter of a model. So class, this is very, very important. Please execute it and try to learn, try to understand what exactly I'm going to teach you. So class, how to perform optimization on the model. So 7.1. So here we are training a model with the name decision tree. So just execute 7.1. So we are building a decision tree on my data set. It run for 7 times. And just see my R square value is 0.5. Average R square value. Okay. And now next, I want get the parameter of decision tree. So class, I use a function with the name plot model, and I am providing two parameter. Number one, decision tree model. Decision tree is nothing but the model that is created in step number 7.1, and I am using a parameter known as plot equal to parameter. So class, for your sake of point, I am just taking the screenshot. I am taking the screenshot and I am pasting on. And here we are getting the accuracy of R square 0.05. So class, just see on the screen. By the default parameter, we get the R square equal to 0.53. Okay. So these are the parameter value. Now come to step number 7.2. So class, this is the most important part of optimization. So here is a function with the name tune underscore model. And we are just passing decision tree model. Okay, the model that we created in step number 7.1. And here n number of iteration are there. So n iteration equal to 200. So just execute it 7.2. So it will run for 200 iterations and it will optimize the parameter of decision tree and just see what should be the performance. Just keep in mind, without optimization, we are getting the R square, mean R square value is 0.53. And just check, just wait and just check, yes, is there any improvement in the performance? So because we are running for 200 iterations, so it may take some time. You can also reduce the number of iteration to 200. Sorry, 50. So we are running for 200 iteration. I think it is getting too much. You can run it for 50 also. It is taking too much time. Let's wait for 1 more minute. So class, in optimization or in parameter tuning, just see here are different parameters. Okay, so these parameters are changed, optimized, and then our objective is that is there any performance improvement? Now processing is 0%. And just see it is showing in the bottom execution time. So it is almost 3 minutes. So class, I'm moving again to the my original regression notebook. I'm just showing you the results. So just 7.3. After running it, I am getting the R square value is 0.75. I am running 7.2 and I am getting the R square value 0.75, and I assign the variable to this decision tree tune model. So I optimize my decision tree model, and I give the new name as decision DT model tuned. And I want to know कि भाई जो decision tree के models के parameter tune हुए हैं उनकी value क्या है. So after that, decision model tune, I use plot equal to parameter, and these are the parameter. Now I'm again taking the screenshot, and now let's compare what exactly the improvement in the parameters. And here we are getting the R square value is 0.75. Okay, so now just compare, just check one by one parameter ki what exactly the parameter tuning means. So alpha CPP no change, 0 का 0 रहा है. Here criteria in the earlier example we used square error. Here it is using absolute error. Similarly, max depth is none, and here max depth is 13. Maximum feature is none. Here it is 1. Again, maximum leaf node none. इसमें कोई change नहीं है. Now minimum impurity is 0. It is 0.05. Similarly, minimum number 7 is 1. Minimum number 7 is 4. Minimum sample split is 2, and minimum sample split is 10, and rest is same. So class, by optimizing these parameter, my overall performance is increased to 0.75 from 0.53. So this is a performance improvement. Class, are you getting something? Yes or no? It is still running. So I am terminating this in between. Class, are you getting something? Yes or no?
Yes, sir.
So this is all about the regression part. Now there are few self-tutorial if you want to apply AutoML, and if you want to deploy your model on AWS or Azure, you can select these links. Okay, so this is all about the regression part. Now one more important thing, you can easily find these links on my homepage. So my website is psrana.com. So point number 3, machine learning using PyCaret. Okay, so this is the link of the complete GitHub page. That this is the link. So class, right now I'm able to just execute regression part. So I'm requesting all of you kindly go through the classification and clustering part. So this is very, very simple. If you know regression, then running for the classification and clustering is very, very simple. So this is a homework for you. So I'm requesting please execute these notebook also. And so this is my phone number and email ID. And if you want to collaborate or if you face any issue, please let me know. So this is all about from my side. So now if you have any question, query, you may ask please.